Hey, Blessing, this is Mr. Green, and this is a recording for our lesson for this week. I will be doing some more star testing this week, and because of that, I cannot be in Class Connect. I apologize. It's just one of those things where I don't have a whole lot of choices in the matter. So, I'm not going to be here, but I wanted to make certain I went over the things that you're going to be looking at for this week, okay? So what we're taking up is trigonometry. Trigonometry is a portion of geometry that deals with ratios in right triangles, okay? So we're going to look at some triangles, and we're going to be looking at right triangles. That means they've got a right angle in them, and we're going to be looking at those triangles from that perspective, okay? Now you're behind in a couple things, so you want to make certain you get caught up on those things. This is one of the last units you're going to be doing, so we need to make certain we get through this pretty quickly, okay? It won't take us long to get through these lessons. Now, the trig functions that we're going to be looking at, and I call them functions because they are functional things. We're going to be looking at the tan, the sine, and the cosine. Now, typically they're referred to in that different order. They usually call them sine, cosine, and tangent. But the way the book the lessons go, tangent is the first one. The tangent is made up of a right, when you look at a right triangle, and you're taking the tangent of an angle. So you have to look at the angle over here that we're looking at right here. That's angle T, okay? And the way you get the tangent is you look at the opposite side, the opposite of the angle side, divided by the adjacent side, okay? Now, if you're looking at angle T here, the opposite side is this one over here, OPP. And the adjacent side is this one down here. Why is this one the adjacent side over this one up here, the 68? Because this one up here would be the hypotenuse. Okay? And that's just, it's opposite the 90-degree angle all the time. The opposite side is opposite the angle that you're looking at, and the adjacent side is the other side that hasn't been named yet. Okay? And the way the tangent works is we always look at the opposite side length divided by the adjacent side length. So 32 divided by 60. That would be the tangent of angle T. Now if I was looking for the sine of angle T, the sine of angle T would be the opposite divided by the hypotenuse. So that'd be 32 divided by 68. And the cosine of angle T is going to be 60 divided by 68. That's the adjacent side divided by the hypotenuse. Okay? So what we do is we come up with these acronyms. This one down here, SOHCAHTOA, SOHCAHTOA. That's the sine, the opposite, the hypotenuse. Well, that's what the sine is. And then the cosine, adjacent and hypotenuse. And then the tangent, the opposite and the adjacent. Now, some people just memorize this word. If you go out there, there's some videos out there about SOHCAHTOA and how to memorize the words and things like that, this word, and help you remember the way these ratios are put together. Okay, but there's also some acronyms you can use. Like one I was taught is Oscar and Oliver have had algebra, because that was sine was Oscar and Oliver, cosine had Oscar and Oliver have had algebra, and that's the way I would write it down. I would write it down as Oscar and Oliver have had algebra, and I knew that was sine, cosine, and tangent. That's the way I always remembered it. Okay, and this was what I was finding. This is what I was the ratio I would come up with. Okay. Now, other people have used some other things. A teacher friend of mine always used to say, "Some old horse caught another horse taking oats away." He lived out in the country and he had horses, so it made sense to him and he could remember it that way. Ones that a college student told me one time was, "Some old hippie caught another hippie tripping on acid." I mean, there's all sorts of different acronyms you can use to try to memorize that ratios, how those ratios are put together. But the whole point is, what we're trying to do is solve for what an angle is, what angle we're looking for, or solving for the ratio of the sides. Okay? Where this came from, Okay, if you remember back in your history, your world history, the Greeks and the Romans used to always fight each other. Okay, well, the Greeks came up with this system. They put this little lighthouse out here, and they put their catapult over here. Okay, catapult with a rock on it, and then they would see this boat sitting out in the bay. It was a Roman boat. Okay, and they needed to shoot the catapult at it. Well, they knew that if they had a right angle right here, a right angle, and they could figure out, they could see what angle this was, okay, by looking at it, looking at the boat, and spying along this, and they could figure out what angle this was. They had it marked on their little lighthouse that they were standing in. They could figure out the angle real quickly. They could relay that angle over here to them, to the catapult, okay, send them little light messages or send a runner over there telling them what the angle is supposed to be. And once they got the angle, they knew what this distance was because they knew this distance down here, and they could use this to determine how far they had to throw that rock. So they knew how tight to make the catapult so they could throw the rock to hit the boat. And that was the goal, after all, was to sink the boat. Right? Those Romans and those Greeks, they were fun guys. Okay? So let's see what we can do with some of this. Well, you know what? One of the things that came out of that was there were some special triangles that were always going to be the same. Special in the sense that they never changed. The 45 45 90 triangle. It There's lots of these out in nature. A baseball field is a 45 45 90 triangle. And if uh, the catcher has to throw the ball from here to second base, someone once asked, well, how far has he got to throw the ball? Well, you want to know that distance. It's a distance there, right? Well, you notice how this distance and this distance are the same on the baseball field. They're always 90 feet. And this triangle that's formed is a 45, 45, 90 triangle. And that's one of the triangles that we call a special right triangle. Why? Because they're always going to be the same. And I could either use Pythagorean theorem or I could use the trig functions to try to solve them, but I'm basically lazy. And being basically lazy, I know that if this number is the same and this number is the same, I can find this distance here by simply multiplying by the square root of 2. See, I've got the same, and same times square root of 2. Those ratios exist in this type of a triangle. So that means since the sides are 90, that must mean the diagonal is 90 times the square root of 2. And that became the easy way to find that distance. Cool? Now there was another special triangle that came up, and that was the 30, 60, 90 triangle. 30, 60, 90 triangle is composed of a 30-degree angle, right down here, a 60-degree angle right up here, and a 90-degree angle. Now, those are things that we can remember. Those exist pretty well. Well, the sides on this one, using Pythagorean's theorem, we came up with that this side was 2 times this side. This side's 2 times that, and then using Pythagorean theorem, we come up with this side over here being the square root of 3 times the smaller side. And these three ratios, these three side lengths, made it real easy to solve these type of triangles. So in this particular one, we got 42 right here. That means that this long distance over here is going to be 2 times 42, or 84. And this AB over here is going to be 42 times the square root of 3. Do you see how that was easier than doing the Pythagorean theorem process of a squared plus b squared equals c squared? If it's worked out for you already, use it. It's easier to do. And these two triangles, the 30, 60, 90 triangle and the 45, 45, 90 triangle, those are special triangles. They occur frequently, and we don't have to use the trig functions or the Pythagorean theorem to try to find any of the values of them. Okay? Now, one of the problems with trigonometry, and it's been around for a while, is that not all triangles are right triangles. Sometimes they're wrong triangles. And that means they don't have a 90-degree angle. But we can still use our trig functions with it because they discovered that if you take the sine of an angle divided by its side, or the side opposite divided by the sine of an angle, it will be the same ratio inside of a triangle every single time. So these two will have the same ratio as these two. Okay, not showing that very clearly. The red two would have the same ratio as the green ones. Okay? And so you can write that down. You can say 9 divided by sine of 88. Where's the 9 come from? This side over here, divided by the sine of 88 degrees, will be equal to u divided by the sine of 59. Well, u's over here, and there's the sine, there's 59, so we can take the sine of 59. Now I'm just going to do a little bit of algebraic manipulations. I'm going to multiply times sine of 59 to the other side. So 9 times sine of 59 divided by sine of 88. And that will be equal to what u is equal to. And that's something you can do on the calculator. Okay? 9 times sine of 59 divided by sine of 88. And it gives you an answer of 7.71. So we find out that u here, where's my pen? There it is. 7.71 is what u is equal to. So we found this distance right here. Woohoo. Okay? Now, we know that we can find this other angle over here, can't we? All we've got to do to find this other angle is add these two together and subtract it from 180. We can find this other angle right there. And then we can do the same thing to find UW. This distance over here. Use that law of sines again. Can't use the Pythagorean theorem. Why not? Because it's not a right triangle. Don't have a right angle in there anywhere. But it is something we can do. Now there is a more complicated theorem. And the more complicated one is this one here. It's called the law of cosines. And the law of cosines looks very much like the Pythagorean theorem. It says a squared is equal to b squared plus c squared minus 2bc cosine of angle A. It's a very complicated theorem, but it's really not that bad. Look, what we're going to try is we're going to try to find this distance right over here, d. Okay? To do that, what I'm going to do is I'm going to take these two sides, 48 and 56, and I'm going to say d squared is equal to 48 squared plus 56 squared. Well, that was easy enough to write down. Minus 2 times 48 times 56, same two numbers, 48 and 56, cosine of 50. Well, there's the angle 50. And by working this out, 48 squared plus 56 squared is 5,440. 2 times 48 times 56, I don't know where that 8 came from in there. That's supposed to be in there. Thank you. It's 5,376. And then I'm going to take the cosine of 50. So I multiply this out first. I get 3455. Subtract this minus this, I get 1984. Remember, we were dealing with d squared. So I take the square root of both sides, and I find that d is equal to 4454. So that means this distance over here is 4454. Now, if I wanted to find the two angles as well, I could use the law of sines and say that the sine of angle E 56 divided by the sine of angle E is 4454 divided by the sine of 50. And I could solve it for angle E. And then add these two together and subtract it from 180 to find angle F. Okay? Now, these are all, the issues that are in trigonometry. And I've covered them all for you here today. Okay? So I know you're going to be rewinding this video and watching it many times. Okay? Because there's some things in here you want to watch over and over and over again. There's also videos on each one of these different topics individually in the video library. So you want to watch that as well. Okay? So, the secret word for today is family. So after you watch this video the first time, you need to send me a K-mail saying that the secret word is family. Okay? And look at what we're doing. We're doing these things here. We're using geometric figures. Let's see here. this one down here. Developing and applying justifying triangle similarity relationships as right triangles, trigonometric ratios, and Pythagorean triples in a variety of methods. That's what we're doing. Okay? And we're using congruent transformations and conjectures. Well, you didn't see us making these transformations and conjectures, but that's the way we came up with these theorems. Okay? So we're using these type of topics. These are the things that you need to learn to be successful in mathematics in the future, okay? So I look forward to talking to you a little bit later on. Like I said, I'm going to be doing star testing all week, but if you need to come to tutoring, come on by. I'll show up when I get there, okay? I look forward to seeing you. Bye.